Okay, so what we're gonna do is I want to make sure you guys know how to take a derivative. So here we're gonna say f of x equal to 4x squared minus x minus 1 over something that say square root x. I want to take a derivative of this. And how would I take a derivative, right? Okay, so that's what we're gonna start with. Just make sure everybody knows that before you take a derivative, you must do like algebra first if you can, because you want to get down to a simple power rule to do this. And this is really like question like 47, I think. So think about how would you approach to do this questions. And I want you to take a derivative of this. Okay. So this is something I will put on a test. Not on a quiz tomorrow, but it will be on something on a test. Kevin's already done. You need to take a derivative of this function. So how would I take a derivative of this function, right? That's a simple reminder in 4th grade. We have a over c plus b over c. If I have the same denominator, I can add a top. But that's a 4th grade, always going this way. In high school, probably sometimes and many times favor this way. So make sure that you can do that. And then I can take a derivative of this. So I'll give you some time to finish this part off, and before we get into the application of it. So you guys done? It should not take long with this, just a lot of algebra. So my first step is always split them. And I'll change that square root to x to the 1/2. Does that make sense? Minus x over x to the 1/2 minus 1 over x to the 1/2. I haven't taken derivative yet. This is just a simple algebra, right? And then I'm going to say f of x. So I haven't taken derivative yet. I'm going to simplify each one. So 2 minus 1/2 is 4x to the 3 over 2. Does that make sense? Minus x to the 1/2 minus x to the negative 1/2. Because I cannot take a derivative as x is on the denominator. Am I going too fast? So far it's okay?
Yeah.
Did I take a derivative yet?
No.
No. So do you see how I write the next line? I write down f prime of x. That means at the time I take a derivative. So it'd be 4 times 3 over 2, x to the 1/2 minus 1/2 x to the negative 1/2 minus negative 1/2 times x to the negative 3 over 2. So that's equal to 2 times 3 is 6x to the 1/2 minus 1 over 2 x to the 1/2 plus 1 over 2 x to the 3 over 2. Now this is the answer I'm happy with. I can move on with this. Now if you really want to be radical form, which is gonna be fine, 6 square root x minus 1 over 2 square root x plus 1 over 2x square root x, and that's the best way to do it if you wanna be in radical form. I don't prefer it, but it's up to you to recognize extra things. Am I going too fast? Nicholas, am I doing okay?
Yeah, you're
Good. Caroline? Trevor? Okay, just make sure you had to take a derivative of every term. Don't just do derivative on one term and leave the other two alone. Sydney? It's good? Are you sure? Okay. Katie? Good? Ethan? Okay. Now we're gonna move on to find equation tangent line. So those will be application of it. So I'm gonna show you how to do one, and I'm gonna show you how do I check my answer if I'm doing at home. When you're doing homework, there's no point doing it until you check your answers. So find equation of tangent line. This is a big deal. Okay, if you know how to find equation tangent line, it's a good 3% to 5% of the test. Out of 100%, this is probably the easiest point. Okay. Also, we're going to talk about, besides tangent line, there's also another type of line. Do you guys know what's a normal line mean? Anybody take physics here?
Oh, like a line of best fit.
Huh?
Like, wouldn't that be like a line of best fit?
Line of what?
Best fit.
Best fit? No. Is what? Anybody take physics here?
I take physics, but I have no idea.
Yeah, I took physics 1, but the only lines we really use are like.
Okay, in physics, in pre-calc also talk about it. So write down normal line means perpendicular line. It's a fancy way of, but usually occur in physics more than in math. In physics, also you talk about something else, which is orthogonal. You might not hear that one before. Have you heard that one before? Orthogonal? Yeah. Okay, orthogonal is 90 degree. And this probably talk about in pre-calc when we're doing something called dot product. Something dot product is equal to 0, then that means it's orthogonal. I don't know if you remember. So what is normal line? So if this is a parallel line, means the same slope, right? Same slope. So this just means, oh, sorry, that's not. This is a parallel line. M perpendicular is equal to opposite reciprocal. Reciprocal. Opposite reciprocal. Now, go back to algebra 1. One of the best tangent line I use is always this one. Is y minus y1 equal to x minus x1. So this usually minus m, oh sorry, not minus m, minus x1, and this is m, and this is y1. So pretty much if you have these three information, that's gonna be equation tangent line. And it's super easy. I'm just gonna do one question, just say f of x is equal to, I don't know, 3 over square root x. Okay. At x equal to, I don't know, 4. Okay. How do I find the equation tangent line? Well, basically what I'm going to do is I'm going to take a derivative. So derivative plugging 4 is going to give me a slope, but so I'm going to draw a line here. This one, right now, 4 is going to go to here. It's already done. You can plug in 4 there. How do I get y1? Just plug in. So y1, right? So y1 is going to be plug in 4. Plug in the x value. So 3 over square root of 4, that's equal to 3 over 2. Does that make sense? How do I find the slope? How do I find the slope? Right. Slope is going to be taking derivative. right? And plug in the x value, right? So if I take a derivative, plug in the x value, so it's going to be f prime of x. Well, before I take a derivative, I'm going to say f of x is equal to 3 over square root of x. F of x equal to 3x to the negative 1/2. Because I have to move to the top in order for me to take derivative. And f prime of x is equal to 3 times negative half x to the negative 3 over 2. Does that make sense? And then I'm going to plug in 4. So it'll be 3. And then this one is going to be 4. So it's going to be 4 to the 3 over 2. Which is 4 to the 3 over 2 is equal to square root of 4 times 3 is equal to 8. So it'll be negative 3 over 2 times 8 equal to negative 3 over 16. So now I'm going to plug in this equation. So it'll be y minus, this one's going to be 3 over 2, right? Because that's a y value. And then equal to m times x minus 4. Which is this 4 is going to be red. And then negative 3 over 16. So that's equation tangent line. So this will be tangent line. And I'll plug in, I will take it, I will do normal line as well. Y minus 3 over 2 equal to 16 over 3 because opposite reciprocal. So this is normal line. So this will be A, this is B. So I will find tangent line, normal line. Now, on your homework, please check your answer. How would I check my answer? I check my answer by plugging to the decimals. So get your computer out and check whether there's a tangent line to each other. You can see it. Okay, so first of all, I'm going to type in 3 over square root x as a functions. So I'm going to do that. 3 over x square root x, that's equal to y, equal to that. Are we okay here? And then we're going to say this is a function, right? And then it's going to be y minus, I forgot, what was it? 3 over 2, thank you. And times negative 3. Nope, so equal to negative 3 over 16 times x minus what?
4.
Do you see that they're tangent to each other? They only that particular part, they only intersect exactly 1 point. Do you see that? And that's how you check your answer, see if it's right. Are we okay? Yeah.
And then the other equation that we got, the 16 over 3, that's going to be like
The normal line. So if you see that, it's going to be y minus 3 over 2.
yeah.
And then it's going to be equal to 16 over 3. And then times x minus 4. You're going to see that's 90 degrees to each other.
Okay.
You see that it's 90 degrees to them. So normal, when you're exerting the force, it's going to be 90 degrees to the floor. So when you like have an incline, and if you have incline, I say things going up, and there's the things like this. So there's some type of force like this, some type of force like this, and I really don't know physics, but those like those incline like blocks, and those are the things that you need to know. So this is the equation of a tangent line. Am I going too fast? No? Okay, yes.
What would it look like if you graph the derivative as well?
If you graph the derivative, it's going to become a brand new function. And we're going to talk about that in more detail when we get to chapter 3. Right now, we just need to worry about a tangent line. Okay? All right, so do you think you need a practice problem for this?
Yeah.
Okay, so I'll give you a practice problem. So if I have f of x is equal to, I don't know, 4x over x to the 3 over 2, at x equal to 16. I want to find the equation of tangent line at x equal to 16. Now, the functional derivative could be harder, right? Depends on the situations, right? So I want you to find equation tangent line and normal line and check on computer, see if it's knowing how to check. Now, normally I would ask you to do it on graphing calculator, since a lot of you guys haven't get a graphing calculator yet. You can also practice on graphing calculator because that's gonna be the key. But usually graphing calculator, I can train you within like 3 weeks, so it's not that big a problem. But you guys all have to get it. How many of you guys have graphing calculator already? You do? Wait, do you have which one you have? Can I see it? You have the Casio one, right? Or HP one? Yeah, that one, I don't know how to work. So I probably had to give you a new one, like a school long one. Caroline, you have it, right? No? Okay. Sarah Z and Sarah Zhang, you can both have it, right? Dav, you have it?
No,
No graphing calculator?
no.
Are you gonna get one or no?
Yeah, I may.
Okay.
Which one do you recommend again?
84 CE, that's the one I will get. Because the other one's unnecessary fancy. It's actually harder to use. So Caroline, do you think you'll get it or no?
Yeah, no, where to buy it?
Target, Walmart. But they are kind of expensive. I usually buy from OfferUp. So I usually buy stuff like second-handed. I never buy, like this computer is. I went to buy from like Craigslist. I buy a lot of, I buy my car from Craigslist. Yeah, I'm serious. It was $3,800, so.
It's a steal right there.
Yeah, it's like Subaru Impreza 2009. That car will run like a. I mean, a car's only get you from point A to point B. It doesn't matter what kind of car you drive. And Subaru is known for a car is not break down easily. You finished? Did you check your answer on Desmos? Learning how to check. Okay, get a practice of how to check. It's gonna be one thing that's gonna make you more successful than other people because you did your homework and you check your answer, you see it's right. Rather than the second day you come check with other people. That can be used as reference, but that computer way to find a tangent line is gonna be much more effective. Oh, also, if you've done the corrections of the test, you can show me and give it, I can put some points on your test score. So, I mean, if you above 75, I probably cannot take any points, but some point I'll put on that.
I'm trying to type faster, I'm sorry.
I will probably simplify this equation just because this is equal to x to the negative half. That's something I would do. Does that make sense? 4x, top minus bottom, right? So 1 minus 3 over 2. So it'd be 4 minus 1 half. So that's easier for me to take derivative. So I'm gonna plug in 16 here. The 4 times 16 to the negative half, which is in this case is what? 4 over 4, right? Does that make sense? Okay. Now I'm going to take a derivative of this to find slope. Now it's going to be 4 times negative half times x to the negative 3 over 2. So that's equal to negative 2x to the negative 3 over 2. If I plug in f prime 16, I'm going to get negative 2 times 16 to the negative 3 over 2. Do you guys know what the answer is?
Negative 128.
It's negative 1 over 32. Yeah, something like that.
Oh, man.
So 16 to the negative 3 over 2 is equal to 1 over 16 to the 3 over 2. That's equal to square root of 16 to the third power. So that means 4 to the third power is 1 over 64. So it would be negative 2 times 1 over 64 equal to negative 2 over 64, which is negative 1 over 32. Does that make sense? And that's equal to y minus 1 equal to negative 1 over 32 times x minus 16. That's the tangent line, and that's the normal line. And
I forgot to put it back in.
so you will have to get x value, y value, and slope. And being consistent, check your answer on decimal. Sydney, you get a computer out, check it. Sarah Z, Sarah Zhang. Make sure you see how tangent line works, and make sure you get a habit, check your answer on decimals. Because that's a best friend. Decimal is going to be your best friend. They are very, very accurate. They are accurate to like it. It's pretty crazy. Now, a lot of the time they give you y value, which is nice. They give you a point. You don't have to evaluate for y. But most of the time, the way I give question is I want a student go out to find a y. Because that's how I ask questions. And an AP exam might ask that way. So it really depends on what the situation is.
I'm confused. Why did you need the 1 over 64 for?
That's just 16 to the negative 3 over 2. Because I just work out this part on the side here.
Oh.
So because I kind of think about, I can come up with that number, but I want to show some people. I can come up with a number on top of my head. It's not a problem. But the problem is some student doesn't understand how I get that number. I show you the progression. You change your negative exponent to positive exponent, and you do the definition of radical. So you do square root of 16 first, rather do 16 to the third power. Because no one knows what 16 to the third power is. I mean, I don't know. If you know, more power to you. But then I don't know square root of that big number. So I don't think I can ever find that. I'm not smart enough to do that. If you are, then more power to you. But even you are, then why would you want to do that? Right? Okay, so the next application. So the first application is the application here that we have find equation tangent line, and normal line. So normal line. But the reason why I want to show you this too, if you something to tangent each other, we're gonna talk about it in a second. So that's the first application. Second application is, how do you find the x value? Right? How to find the x value where the function has horizontal tangent? Have the big name here is called horizontal tangent. It's very, very important. What does horizontal tangent mean? What does a horizontal tangent mean to you? And how do I find it? For example, what if I give you a function like this? Y equal to x cubed minus, I don't know, x, right? How do I find the x values where the function have horizontal tangent? What does horizontal tangent mean to you? If I hear this word, what does that mean in math? No. Yes.
So just like a slope of 0.
Slope equals 0. So how do I do to this function to do it? Slope equal to 0. How do I do it? Caroline? No? Deb?
You said x equals 0,
Not say x equals 0, but
y equals 0.
no.
Would you like find the derivative and then set that to 0?
Yeah, what does derivative mean?
Slope.
Derivative means slope, right? This means derivative, right? Because this is slope, right? And horizontal means the slope is equal to 0. So that means what? If I see horizontal tangent, means set f prime of x is equal to 0 because slope is equal to 0. Horizontal means slope is equal to 0. Does that make sense? So can I take a derivative of this? 3x squared minus 1 and just set that equal to 0. Anytime you doubt in math, I always just say derivative equal to 0, you always find something. Some type of answer for something. On AP exam at least. X squared equal to 1 over 3. X equal to square root 1 over 3, that's it? Or no? What am I missing? I'm missing something. I'm missing what? Thank you, plus minus, right? Don't forget, right? Don't forget. So on your today's homework, you got to, we say find the horizontal tangent, derivative equal to 0. Take a derivative, set it equal to 0. Solve for x.
So that's it for finding the horizontal tangent, or is there something else?
That's it. That's it. You want more?
No, it seemed like it was more complicated.
No. I think it's because people make it more complicated than it is. Math is very straightforward. Oh, yesterday, no. Oh, my student sent me a homework from MIT, a multivariable calculus. I was like, what the hell is this? I was literally like, I have no idea what you're doing. And she's in the multivariable calculus. She was like doing, I don't know, it's like some crazy stuff. Homework is like 1 page, and that 1 page has so much work. I was like, ah. But that's complicated. This is easy. Does that make sense? Now I'm going to give you the next question. The next question is a little bit more difficult. They say, hey, the next question says find the k value. This is, I call it infamous k value problems. So k value such that the line of tangent is tangent to the graph of function. So here's the functions. The function is going to be f of x is equal to k minus x squared. And the line is y equal to negative 6x plus 1. So I have this situation here. F of x equal to k minus x squared. And y equal to negative 6x plus 1. And we say, hey, can you find the value k, which is this k value, I'm going to change it color so that way you know that's the value I'm trying to find. This k value, where they are tangent to each other. Okay, so what in the world does that mean? I'm going to give you a clue. Go back and look at this image. Look, if something that is tangent to each other, there's two things they have the same. What are those two things? X and y, okay, the coordinate. The coordinate is gonna be the same. Okay, that's the first thing. What's the second thing? They are the same. If something tangent to each other at this point, what else is the same? Yes, x and y is going to be the same, which is the coordinate. What else is the same? No. Who says slope? Good, slope. Pay attention to slope. Look, at that point, do they have exact same slope? They almost have the same line. They are same slope. If you look at microscopically, right? So then you say, okay, how do I do this problem? Now I'm going to show you what this problem is. So I'm going to show you this question, which is k. What is it? K minus x squared.
Yeah.
And what is the equation?
Y is -6x + 1.
Y equal to 6x minus 1. Right? Negative 6x plus 1. Okay, so I'm going to show you this. And a slide, okay. Okay. So that means I'm going to let it slide. And you're going to see, told me when to pause, it'll be tangent. Right there, right? You see that? I'm going to do it again. So I'm going to wait until that. Hopefully I have good hand-eye coordination. Oops. Nope, that was totally bad. Right there. Something like there, right? Something between, I don't know, -6 or something. No, this is not the way you're supposed to find a k. I want you to do it algebraically. Your goal is to find out a k right here. Let's think about how, instead of me telling you how to do it. Two things. First thing is the coordinate are the same. If we are tangent, that means input output is going to be the same. Second thing, slope are the same. If we're tangent to each other, tangent to each other. And I want to help you. I want you guys to come up with it. What time we get off here?
9, 10.
Okay, I'll give you 3 minutes to figure out. Go. Yeah. You can work together if you want. You know it's roughly between 6, -6 or -8 or -9.
Yeah, I think so.
Sure. Find the value k such that line is tangent to the graph of the functions. So that means they're going to be tangent with each other. Kevin, you got it?
Does k have to be a number?
Yep. It's probably between -5 to -10.
Never mind.
You guys got 2 more minutes. Talk to each other, collaborate with each other.
Oh, yeah, I just didn't do that. Do that. No, you can do that. Do you think we're supposed to have takes it?
do that.
Okay, so from there, you do, if you do like the derivative maybe, right?
Yeah,
I don't know why you did that.
that's what I did. Then I don't know where to go from there.
I don't know.
Oh,
Maybe derivative like k and then it was a square root of one.
yeah. K is just K is a number, so it'd be 0, right? Negative x.
K is not 0.
No, I said it's a number, so the slope would be 0.
Negative form, right? Yeah. What if we could take the derivative again? Wait, where did we say that the answer was? Can you go to the horizontal tangent? Because I think the derivative.
Horizontal tangent is not going to help you here. But horizontal basically take a derivative set equal to 0. Solve for x.
Close to negative 5.
No, that's not, you can't just say it's close enough.
It's close.
No.
No?
We know Katie cannot be engineer.
It's
It's close enough.
I was gonna say, we checked the homework yesterday, and she's like, yeah, I just changed the sign so much of this,
That's not okay.
That's why I redid the homework.
We didn't have to redo all of it.
Nobody can come up with it? Okay. Can I go over it? Yes? Okay, first of all, understand slope as same. How do I find slope? Well, if I find slope, I'm going to take a derivative of this side, right? Y prime is equal to negative 6. Does that make sense? F prime of x is going to be what?
Negative 2x.
Negative 2x, because k is going to go away. So, negative 2x. Right? Can I set them equal to each other? X is equal to what? 3. Now, can I set the original equation equal to each other? Because the coordinates are the same, so that means input, output are the same. Does that make sense? Does that make sense? So can I plug in 3? Am I doing okay? K is equal to minus 18 plus 1 plus 9, right? Which is what? Negative 8. And look at here, negative 8. Look at that, that's beautiful. It's tangent to each other. There's only one value, that they are tangent to each other. And we just find it by using the idea of tangent. If tangent, they have to be next to each other. If they're next to each other, they have to have the same slope. If they have the same slope, it must equal the same output. So those are things that you have to consider when you think about math. What is this implying? What is this inferring? And yes, you have to be precise. You cannot be like, yeah, I got 7.2. That's roughly right. That usually never work in math. Even if you got 7.1, I'll get mark it wrong. And you'll be like, that's a 0.1 away, but it's still wrong.
I don't know how to solve the problem yet.
But is it hard?
What?
Is it hard?
No, I just don't know how to do it.
Now you know. But you should discover how to do it before I teach you.